Welcome back to another episode of Solidity Fridays with myself, Ben, Rory, and William. And we have a guest today, Jeff from Notional Finance.
Yes.
Welcome, Jeff. It's great to have you on. I don't know a whole lot about Notional Finance. I'm kind of coming in blind here. It does look like a lending protocol. But I'm sure there are some interesting nuances that we're going to get into here. But Jeff, why don't you give us kind of the intro about yourself, I guess, and about Notional Finance?
Yeah, absolutely. So Notional Finance started about 2 years ago. I met my co-founder Teddy at a blockchain hackathon in San Francisco, and the goal was to build a fixed rate lending and borrowing platform in DeFi. So we had just kind of seen Compound come out, and we were really excited about like the idea of like permissionless like lending and borrowing on chain, and that was like a really cool idea. But we were both of like kind of the mindset that for kind of like a lending and borrowing product to be actually be useful, you need to have like fixed interest rates. Mostly because like in the real world, when you outside of DeFi, when you lend or borrow money, it's vast majority of the time it's going to be at a fixed rate, right? If you borrow money to buy a car, it's like X% interest fixed for like 2 years or whatever. And also on the lending side, like what 80% of U.S. debt is issued in fixed rates, right? So like lenders and borrowers kind of prefer that like certainty of like knowing what the interest rate is. And so that's what notional finance is. It's on Ethereum. It's fully fully on chain. When you lend or borrow money, you're kind of interacting with something that's sort of like a hybrid of Compound and Uniswap. And I kind of say that in the sense that like Compound, there's like a collateralization ratio. There's lenders and borrowers. That just those types of concepts. But when you lend and borrow money on Notional, you're actually trading. So you're buying and selling something we call Fcash. Fcash, for people who are familiar with finance, it's very similar to like a zero coupon bond. So we have a number of maturities that are sort of active at any time. And so let's say, just for example, like 1 year Fcash. So 1 year Fcash matures 1 year from today. And when you have 1,000 1 year Fcash, that means you're going to receive 1,000 DAI in a year. So in order to buy that 1,000 DAI in a year, you may pay say 900 DAI today. And so the exchange rate between 900 DAI and 1,000 1 year FDAI implies something like a little more than like a 10% fixed interest rate. So once you buy that Fcash, it goes into your portfolio, it sits there, and what you've done is essentially like you've made an exchange and you've fixed your interest rate. So your interest rate won't change. You're going to receive that 1,000 DAI in a year, but the interest rate for the next person will change, right? So the AMM will sort of readjust itself and present like a new exchange rate to the user. So and just kind of like to finish up there. So like Fcash, a positively valued Fcash is like lending. You're going to receive 1,000 DAI in a year, and negative Fcash would be borrowing. So you owe 1,000 DAI due in a year, and you'll like receive 900 DAI today. So yeah, that's kind of like the short of it, I guess. But there's probably lots to dive into from here.
Okay, super interesting. So I mean, just on the negative sort of the debt position or the asset position, which would be positive, is that reflected in your wallet? Is it like an ERC20 where you have a negative position, or is it how do they do that? How do they do a negative?
Yeah, so it's not an ERC20 token. We are going to wrap Fcash as an ERC20, but it doesn't really function as one natively. The reason for that is that you have this like defined maturity date, right? So
Yeah, all right. It's an NFT.
So once that arrives, sort of you received your cash, it sort of converts into DAI, and sort of you can't really transfer the token anymore. So we represent Fcash as an ERC 1155. So every Fcash asset is defined by a currency type and a maturity. It's like you can think of it as like a tuple, and then some like signed integer value, right, as a positive.
Okay, so then that forms sort of the ID in the ERC 1155.
Yes, that's correct.
Ah, very interesting. Okay. Is there anything more to unpack on the site here, or should we dive into the code?
I mean, just to give the user kind of like an idea of what it looks like, if you click on lend at the top there, yeah. So you can kind of see the four currencies that we're offering lend borrow right now. If you click into like maybe USDC, we can take a look. So the first thing you'll see is the chart. So that's the yield curve, and this is something like probably very familiar to bond traders. Although they're trading T-bills, they'll see something much larger. But you'll see that there's three different interest rates for the three different maturities. And you can also see when they're due. So they're coming due March 29th, June 27th, and December 24th. So there's slightly less than their what we would call their tenor. So the tenors would be like 3 months, 6 months, and 1 year. And this is sort of like, this is part of like Notional is like, is that, we can't provide liquidity on like any arbitrary date. So we sort of have to limit it to like, specific dates. And so this is kind of what we have. And so if you click on a maturity there, maybe like choose, so you can, choose like December 24th. Yeah, so you can kind of see like as you lend more money, there's slippage, and the interest rate actually decreases slightly as you go. And so if you scroll down on the page a little bit, we have a little table that gives people like a sense of the depth of each one of these markets.
That's super cool.
So that's just kind of give you a sense of like what the user experience would be like.
Yeah, I think this is, as far as DeFi goes, this has got to be one of the much better user experiences I've seen. I think the yield curve graph is very, very slick. This is nice, and it just, everything sort of re-renders very fluently as we change the numbers here.
Yeah, I mean, to do this, we actually replicate the entire liquidity curve on the client side. So we recalculate it inside the client.
And like if I click there, it starts highlighting that sort of duration on the table. That's very cool. And there's like readable interest rate as well. And so because it's fixed income, you guys, it's guaranteed that you'll receive this much interest, I suppose.
Yeah, absolutely.
Yeah. All right. Very nice.
UX is really, really good. Yeah, I second that. Since you're guaranteeing, does that mean that there has to be a counterparty or like a fixed depth to any of the pools?
Yep, that's correct. So the thing about Notional, the part that makes it like Uniswap is there's besides just lenders and borrowers, there's a third party, which are liquidity providers. So we have like a unique way of providing liquidity in Notional. So in Notional V1, like we're looking at Notional V2. In Notional V1, what you would do as a liquidity provider is you would sort of deposit USDC into, say, the June 27th maturity, and then so you would be both a lender, you would either be a lender or a borrower, depending on what the user wanted to do, right? So you kind of like Uniswap, you'd be just taking the other side, and you'd earn a trading fee for that. Now, the issue with that is like it's kind of a bad user experience, because once the maturity comes due, like you're no longer providing liquidity, and then you have to like go and like move your liquidity into like the new maturity and like sort of like roll your cash forward. And it's just it's not like a 100% passive activity. So we put a lot of effort into this in Notional V2, and what we have is something called the N token. And the N token is an ERC20 token, and you deposit cash into it. And what it is it's like a managed liquidity provider. So when you do that, you're going to be providing liquidity on all three of the markets there at a like predetermined ratio. And then every quarter when we like initialize a new set of markets, so every quarter we're going to like push the markets out another 3 months. We're going to like just roll your cash with that. So like every quarter we like run a transaction. It's called the initialized markets. We push all the markets forward, and like all the N token holders like continue to provide liquidity sort of in perpetuity. So that was like a massive change to the protocol to make that possible. But yes, there are a few flags. Sorry if that was a little long-winded.
Very cool. No, that's great. What do you say then? Is there something? Do you think there's something else we should see here, Jeff, or should we jump into the code?
Now we can jump into the code. I think let's just give it a taste of it.
We just have a question from chat, which is from Ryan. What front-end framework are you guys using?
This is React.
Yeah, so I see my reactive tools are sort of popping up here. But anything else? Any sort of CSS framework?
Yeah, Material UI for a lot of the components, and then that's about it. Yeah.
Very nice. All right.
It's mostly like I will say this is all like we have an awesome designer, and like kudos goes to him to like kind of putting all this together.
Yeah, the great design in DeFi and crypto makes all the difference. This is like
absolutely.
Not a lot of great design out there, and when it comes in, it's like, oh wow. Awesome. Yeah, I think we're ready to jump in. What do you say?
Sure.
So where should we start here? Is there a README that we can?
You're looking at the README, dude.
Yeah, you're looking at it. I would say, we can take a look at the README. Sorry about the lack of resources here.
No, that's
I've seen far worse READMEs than this. I wouldn't worry too much about it. Yeah.
Sure.
Maybe that tree bit above, Ben. That might be a good place to start.
Yeah.
So what do we have here? We have contracts subdividing into other folders. So we've got external, which Jeff told me before we started, are the kind of user-facing. Global is for storage, struct, and constant definitions. It makes sense. You'll like define structs there that you can like then pass around easily and share between contracts so that you don't have to rewrite them in each one. Internal, shared internal libraries for handling generic system-wide functionality. So that's things like how to get internal balances and how to transfer tokens, calculations for liquidation. Can you scroll down a bit? Key, math libraries, and mocks for testing. Cool. So Jeff was saying before that internal is going to probably be more like the mathy, low-level-y stuff, and then external is going to be more the like user-facing kind of parts of the contract. Do you have a particular preference, Ben?
I don't really have a preference. I don't know.
I'm kind of feeling the low-level-y personally. So right. If you don't, maybe internal.
Let's do internal. All right. Where should we start here? Balances, liquidation, portfolio, settlement, valuation.
Maybe balance. Does balances sound like a good starting point? I'm kind of guessing and say it strikes me like kind of a primitive that'll probably end up getting passed around a bit.
Yeah, we can
you guys
okay, so there's some interesting stuff in balances we can take a look at.
Okay, cool.
Yeah.
This is a library. I see you guys have a README in that of
Yeah,
there,
yeah, you
actually.
could
Do you want
pop that
to check
open, yeah.
everything? I actually really like nested readmes personally, so like, you know, that was a place in my heart. I think balances keep starting.
Let me just put that there. There we go.
Doing account balances, all logic related to token transfers, and incentives for incentive cleaning. Okay. All internal balances are represented in internal token precision, which may or may not match external tokens. Whenever there is ambiguity, variables are marked as internal or external to note their precision. So what does that mean? That means that the precision between like what the user sees and what the system uses differs?
Yeah, so like DAI is like 18 decimals, right? Precision. We like, so it takes up a lot of storage to keep like numbers that big. So we scale everything down to 8 decimals when we transfer
interesting.
in and when we transfer out. So we truncate anything past
Interesting. There was a famous little piece of financial crime, I'd like to say in the 70s, I could be wrong, where a worker in Chase Manhattan managed to edit the system so that Chase would round off 1 decimal earlier, and he siphoned the extra decimal place to himself. I seem to remember he was caught because he was living outside his means. Actually, that like it went undetected and ended up netting him like massive amounts of money.
Right,
I think he was making tens to hundreds of thousands of dollars a day.
Right, the
Sorry?
office space. This is like the office space.
I think that's where they got it from. Yeah, it was actually a real life story first. So I'm wondering, do you see profit from that? Just out of curiosity, because like that's eight places. It's much farther down.
Absolutely not. Actually, if you want to like, there's like a long. I think in Token Handler you can look at it if you want. There's like a long explanation of like when and how like this truncation can get us into trouble. And then like handling like the off by ones, accordingly. So I imagine it. Yeah, it's not like it's quite a small amount of money.
I mean, you're probably not moving a Chase Manhattan level volume per day yet, but I could be wrong. You kind of never know with DeFi, if you know what I mean.
We're not. Yeah, I mean, like it requires like a lot more. Like, I think it would require a lot more number of transactions. In any case, like the accrual would come into the protocol if this does that.
Okay, cool. In terms of end tokens are always one-to-one with the token that is tradable on Notional. Therefore, end token balances are stored alongside token balances to save storage slot. End tokens are incentivized, and their incentives are automatically claimed every time. Actually, what do you mean when you say stored alongside there? End tokens are always one-to-one with the token that's tradable on Notional. Therefore, end token balances are stored alongside token balances.
Yeah. So end tokens are like the liquidity token for Notional, right? So like if we were to list DAI, so DAI could be listed in 2 forms. DAI could simply be collateral for lending or borrowing and could not be lent or borrowed fixed. Or we can enable it to be lent and borrow fixed. If it can be lent and borrow fixed, it must have an end token, like it must have liquidity. So like in a 32 byte storage slot, we like break it up, and so like it's like this is like your DAI balance, and like you either have DAI cash, or you have DAI end token and DAI, and so we like store those 2 values. We also store like some counters for like how much incentives you've earned as well.
Interesting. So I'm guessing now, even from the descriptions, we're going to see a lot of kind of almost like pointer-based code that, like, storage slots that are storing multiple things, and you kind of have to keep track of where in the slot different values are.
Yeah. We use there's a lot of like bit shifting and stuff in there.
Oh.
Yeah, you can have some fun.
All right. Yeah. Okay. Cool. Invariance. Contracts should never have underlying token balances. All token balances should be in asset tokens and never actual underlying total asset cash balances should also be the sum of all account balances, market cash balances, reserve balances, and end token cash holdings. Okay, cool. I think I'm good, Ben. How about you?
Yeah, I'm good as well. What is it when you say contracts should never have underlying token balance? Does that mean the underlying tokens are all stored in some sort of central, I guess, treasury, or what happens there?
Yeah. So okay, man, the system's complicated. Okay, so Notional never holds token, like we never hold DAI straight up. We always we want all of our assets to be earning some interest. So when you deposit DAI into Notional, we go lend it on Compound immediately, and so that way all the cash on Notional is like always earning some amount of interest.
Oh, nice.
So that's what we would call an asset token. Because like right now we just support Compound, but I think in the future we'll also be able to support Aave.
Okay, nice. So yeah, so it's like literally coded that it actually doesn't make assets unproductive. They're never stored here. It's just they're kind of always in this productive form, lent out through Compound.
Yeah. Sorry.
Awesome. All right. So should we get into one of these contracts? Token handler, incentives, or balance handler?
Sure. Yeah. Yeah, we can do balance handler if you're that open. It's a big file. Sorry. You asked, so there's yeah, this is a fun one. You asked, I think there's like set balance storage or something like that as a function in there. I think you asked about like packing, so we can take a look at that if you want.
Don't want to drive you like too nuts, like pop quiz on like bit shifting in the middle of
no. Let's try it. It's like further down probably.
Okay.
It's just underscore set balance storage. Yeah, right there.
The
It's
internal.
368 a little bit. Yeah.
There we go. There we go.
Yeah, right there. So right, so there's some stuff going on here. So on line 376, you can see that we're getting like the storage slot. We don't get it like via the Solidity native way. We get it through this like lib storage thing. And that's so that you can access storage from inside libraries, since we're like inside a library right now. And then so like it gives you back that mapping there. So we have a mapping between like an account, so that's just like an Ethereum address, and like a currency ID. So we assign every currency we list like a number, like 1, 2, 3, 4, 5. So that'll get you your balance storage struct. And then there you can kind of see that we sort of like we should like convert everything down from like a 256-bit kind of integer assigned. So we sort of like make sure they adhere some type bounds and then go ahead and like assign it.
Okay.
Yeah.
Whoa, yeah, there's a lot to take in here. First, actually, I totally don't want to go on a side quest with this, but like, I think this may be the first time I've seen a mapping set inside a function. Like, I'd love to dive into that lib storage thing a different time, but like, I don't want to get like perfectly sidetracked with it. Like that is really interesting. I'm gonna try and remember that actually.
That's a good point. I've never seen that before, mapping sort of defined in a function, but yeah, wow.
Yeah, 0x does it as well if you want to look it up.
Ooh, okay.
All right, so. And so this lib storage, I want to kind of just flag this for maybe just either later today in this episode or a future thing.
It's in the global.
All right. Yeah. That looks very interesting. So is the idea here, it's a library for storage so that you can kind of get specified points or specified slots, and then that's all right. Wow. Okay, a lot to digest. But essentially what we do is we just create this mapping within the function, and we populate that, and this mapping obviously points to some space and storage. and we're populating that here. We're going to start populating it with all of these things.
Yep, exactly.
Ah, cool. So yeah,
so
379.
it's just regular storage packing. It just lets it.
Yeah.
Yeah, 379 is just checking for an overflow since we're going to be casting into int 88. It looks like. Clear int token balance greater than or equal to 0 and less than max. So yeah, another overflow. Check on 381, 382 last time claim. Has to be less than that, and another one for uint32 there. Okay, cool. Balance storage dot int token balance. Truth is, I don't know if you know the answer to this off the top of your head, but definitely something I've been meaning to dive into more as a dev is when we're talking about packing in numbers, at what point the casting becomes problematic in actual gas efficiency. Like, is it always worth it to like pack down and cast when necessary? Or can casting in between types itself become enough of a gas burden to make it easier just to keep things in 256s?
So on the stack and in memory, you just always use 256. It's less efficient to cast in like outside of storage, but you definitely want to cast. Like you definitely want to cast from this. Like,
for anything in storage, you're saying the casting's never gonna outstrip like the actual cost of having to like store one of those beefy 256s somewhere.
Yeah, absolutely. I mean, like the gas cost on the storage thing is like it's like 5,000 gas minimum, right? But like casting it on the stack is like what, like 3. So, yeah.
Cool. Then yeah, 384 through 386 is the population, like Ben was talking about. Putting in the end token balance, the last claim, and the current cash balance. Okay, cool. Then balance storage dot packed last claim integral supply. So then you have this. I'm assuming that pack to 56 bits is like a helper function that you've created in order to kind of pack data into something like recognizable inside the system.
No, this is like
Herbs.
This is a dirty little trick. Okay, so we don't have enough space to store. We don't actually like to store the precision of this value that like the full precision of the value. We don't actually have like enough space in the slot. So we truncate it down to 56 bits using this like floating point, quote unquote floating point method. Yeah, if you want to look at some bit shifting, we can look at that. It's a bit of a side quest though.
Sure. So yeah, so let's stay on this then.
Yeah. But it's just because like we ran out of bits on the spot. So we chose to lose some precision on this
one. All right.
Thank you. All right, cool. So balance storage pack last claim integral supply. Again, so that's also another field inside this. Like I'll just call it a struct, I guess. Yeah. Oh, it is a struct, I think.
Well, yeah, the balance storage.
Yeah, it's struct.
Okay, sweet. So then that populates this, and which contract is this actually stored in, this slot in memory?
Actually, so this is a good. Maybe we should start here. So actually, in the root, there's like a folder called images.
Images. There we go.
Yeah. So okay, open that up. So.
Wait, is that okay? There we go. Oh, sweet. There we go.
Yeah. Okay, so like, okay, so we have this like it's like the diamond pattern, I guess is what you can call it, but like that's how the whole thing is set up. So we have like an upgradable proxy that's like the OpenZeppelin proxy, and that's where all the storage is. And then it does like a delegate call to like what we call like a router contract. And that contract is like implementation on the proxy, but it's like it doesn't do very much. It's quite thin. And it like sort of does another delegate call off to like any number of like external contracts. Right. So everything gets stored, like everything that happens in Notional is stored in one like storage on one contract. even though there's probably like 15 or something deployed contracts that actually have like implementation logic.
Let's see if I remember my delegate call foo. That second delegate call, it happens in the context of router, it happens in the context of the upgradable proxy.
The proxy.
That actually happens in the proxy. I don't remember that right.
Right, because like you're in the router, you're in the context of the proxy still, and then when you delegate call again, you're still in the context.
So you still keep it. Yeah, okay, fine. I was trying to remember what happens when you nest this.
So that's quite elegant. So yeah, there I see the diamond pattern sort of coming in. That so everything sits in storage here, and we just delegate call in the context of this storage to these various modules. Is that correct?
That's correct.
All right, nice.
And so this is kind of like to bring it full circle. This is where the lib storage thing actually comes into play, because like when you're like that deep in a delegate call, like you don't necessarily relying on how Solidity compiles the storage slots is like not reliable. And so in lib storage, what we do is like we actually like we use assembly to like look up specific storage slots on the storage tree. Like we kind of manually know where we need to go.
Okay.
That is really cool.
Yeah.
Could you dive into that for a second? Because I'd been reading into that a little bit recently, actually, about kind of like the lack of guarantee that Solidity has about storage slots and why you would need to dive into yield to get that.
Sure. So, so like the way Solidity does it, like if you start creating storage slots on a contract, it'll go, you know, first thing that you declare is storage slot, I don't know, 0, and then storage slot 1, and just kind of like auto increments it. Now, if you start to have inheritance, it gets a little weird because like it's like you can't just look at a contract and know like who's 0 and who's 1. And then if you flip around, you know, inheritance, maybe that'll like mess it up. And then also like if you just like add a new storage declaration in the wrong spot, like between two other storage slots, and then you go upgrade your contract, you're gonna blow it up, right? Because like what was storage slot 3 is now referring to something else. So that's like it's quite error prone to do that. Now it's good enough for like quite simple contracts. If you just have like 3 storage slots or whatever on this, one file contract, like works great. But for a more complex system like this, where you have like 15 contracts and like they need to access the same data, it's not like a reliable way to do it. So if you like look at lib storage, it makes it easier just to kind of drag it. What we're doing is so the way you have it. Oh, yeah, you have it. Yeah. So the way Solidity, the way the EVM stores storage is that like if you have storage slot 0, it's just going to take the 256 hash of 0, and then like that's going to be a storage slot, right? So it's like every storage slot is just like a 256-bit like address, right? Like specific to your contract, right? So and then the mappings will be like multiple values, like sort of packed together and then hashed, like sort of like so you end up like always getting some sort of like 256-bit number that marks like where the storage is. So knowing that, you can sort of like take advantage of that to like just sort of like kind of like directly manipulate the storage tree. Because like as long as you can reproduce the hash location of where your data is stored, you can always get back to it. Does that make sense?
Yeah.
Yeah.
Nice.
So here what we do is like we just reserve, I believe, like what is that, like 1 million? We reserve like 1 million slots for like native Solidity, so that's like 0 to like 1 million, and then off of that, we have this enum starting on line 22. So then off of like that, so then we'll go like 1,000,001, 1,000,002, 1,000,003. So like these are like provisions through this library. And so like 1,000,001 slot is for account storage, and then what exists there is I don't know, some sort of mapping. So if you look at like line 43, yeah. So from that slot, so that slot 1,000,001 is going to be like the first like element in the hash, and then the second element in the hash is going to be an address. So like you hash those two things together, and then you get yourself a slot.
Very nice. And so you see it. Well, we're not even just defining a mapping now, we're returning a whole mapping. I haven't seen this before either.
Yeah.
Yeah,
so,
if you look back, oh no, go for it, Jeff.
Oh yeah, so okay, so what this does actually, like, I don't know like the actual mechanics in Solidity, but like what it doesn't actually like, it's actually like it's a function, right? Like the mapping is a function, and then like what Solidity does is that, like it's gonna do like what that thing actually unwraps to is like it does a hash. It like does a kekak hash, and then like returns like some other assembly that like does an S load off of the result of that hash. So like yeah, no, sorry, that was maybe too low.
Yeah, like I guess that makes sense. It can't possibly reject the whole mapping. Like they actually have to know where everything is, which is like kind of the whole point of the mapping is that it doesn't. Yeah.
Okay. Jeez. I think this is like a very elegant way to do storage. Wondering if we should start replicating this sort of thing in projects. Yeah.
I'll give kudos to the 0x guys, because like I was kind of using like this and it wasn't as elegant as the way it's set up here, and I was like looking at their code base and they had another way. So that's where I kind of picked a lot.
Shout out 0x. All right. Is there anything else to dig into here? So then for these first 1 million slots reserved, is this for sort of user data that goes in there?
No, so if you go one file down, storage layout v1.
Sorry, which one?
So in global, there's like a file storage layout v1. Just under lib storage in the tree.
Oh, I see.
Yeah.
This one.
Yeah. So in here, like here, this is like actually like starting from 0, like some storage slots that we've like reserved for some other stuff. And I think we did this mainly because like, this stuff, it's like a little bit easier to use just Solidity storage like this. So there's some storage values where we just kind of still just allocations.
Awesome. All right, should we dive into some more internal logic here?
Code. Sorry.
All right, I don't know. Is there anything more to cover on the balance handler, or should we get into some other part? I mean, obviously.
Yeah, we can go wherever you guys want.
William, what are you feeling?
I don't have like a good like instinct right now. I think it would be good just to bounce into something else. Yeah, let's do that.
Valuation, asset handler, exchange rate could be interesting. Free collateral. Jeff, what do you think?
Yeah, I mean, if you look at, I would say like out of those asset handler, maybe take a glance apps. It's probably the most interesting thing here. Okay, so what do we got here? So okay, so we have get settlement date. Okay, how do you guys like date math?
That's true. Yeah, like I don't think I've ever actually coded a project where I needed a high level of data accuracy, which is interesting. Like I've never really had to worry much about it.
What can I say? What's going on here? Okay, so this is like the hardest thing to explain about Notional.
Ooh, we found it.
No, it's just like conceptually like hard to wrap your head around. But okay, so Um, so, okay, how to explain this? Okay, right now, we have 3 maturities that you can trade at. You can trade at March 29th or whatever, like end of this month, June something 27th, and then like I don't know, December something, right? So it's like about a month away, like 4 months away, and I don't know, 8 months away. So like, yet we promise, like a 3 month, a 6 month, and a 1 year market, right? So we're not like, we're less than like what we promise, right? The reason is that like we have these like we have this like recurring like quarterly market cycle, where like at the very beginning of it, it is 3, 6, and 1 year, but like as time progresses, right, like you're trading like the time, like the maturity is getting closer and closer to like current time, right? And so, but like every 90 days, we have to like, we want to push those out. So like we get back to like what we're promising you, the 3, 6, and 12 month thing. So what's happening here is like, we're calculating for like a particular like asset that sits in a portfolio. Like when does it actually like cease to exist? And so for Fcash assets that we talked about, so that's like the on line 31, Fcash asset is like 1. So like it ceases to exist at maturity. But any like these liquidity tokens, like people providing liquidity, they cease to exist at quarter start plus 90 days. So like every time we like push the markets forward, like they need to like get settled. They need to they need to like cease to exist. So so that's kind of what that last line 38 math is doing. It's sort of like back calculating like where like a particular like liquidity token needs to like actually like get sort of deleted from the system. Um, I have no idea if that would like make any sense at all. Yeah, sorry.
I think so.
Okay. Anyway.
Yeah, awesome. I'm like vaguely grasping it, but yeah, it does make sense. Okay, any other interesting functions in here that we should get to? I mean, there's a lot of financial math I see going on with that.
Yeah, so continuous compounding, that's what that is. So it's like earning what 10% for however long. It's going to like get you a discount factor between 0 and 1, which is like how much what's the present value.
Yeah. Okay, nice. Discount factor. And this, okay, so we're dealing with, well, between 0 and 1. Interesting.
So yeah, so you asked about casting on the stack. So actually, the casting signed ints to uints is like, it does cost a little bit. So we tend to do all of our math in signed integer because like I said, like Fcash can be positive or negative. And so if we're just doing everything in signed integers, we don't have to cast again.
Nice. Okay, yeah, that makes sense. And then we get the present value of an Fcash asset without any risk adjustments. Okay, that's pretty interesting. So then I guess this is just standard like present value with a discount factor. But then what would these risk adjustments be with risk adjustments? Yes.
Right. So, okay. So, so Fcash is what we consider like what we call a risk asset. And so risk asset means something that can change in value due to like external conditions, right? So this kind of interesting concept. So right now, like if you lend money on Notion right now, you're gonna fix an interest rate like 5% for your time to maturity. That's fixed. That's not going to change for you. However, the value of that Fcash will change. right? And its value is what you can sell it for back to the market at the current point in time. So if you have right, so like that's essentially saying like if interest rates go, I always get this mixed up. So it's like so if you lend at 5% and interest rates go down, so it gets like I don't know, yeah, interest rates go down. What you can do is you can like borrow at 2% and you can earn the 3% spread. So your F cash got like more valuable over that time. Conversely, if interest rates go up, like your F cash got less valuable because like instead of lending at 5%, someone can lend at like 8%, right? So the value of your present value of your F cash has gone down. It's like being discounted by 8% rather than 5%. So what we allow in Notional is you to borrow against F cash. So like you could say you see like a nice juicy, 8% interest rate out on the 1 year, but you don't have the money to lend. You can like borrow from the 6 month, right? Borrow at 5% and then lend at 8%, right? And what you have to do is you'd have to hold capital on the difference between those things, and we can't have it be zero. So what we do is like we like increase the spread by like I don't know, like changing the interest rates a little bit by moving the interest rates up and down a little bit to force you to hold some capital on that spread. So that's what this is doing. It's like we can set adjustments to the interest rate to make you hold more or less collateral against your cash. Sorry, that was like I tried to explain bond trading. I'm not a bond trader, so my apologies if I didn't do that right.
No, I kind of grasp it. Yeah, I have like a bit of a background in finance, but definitely not at sort of the bond trader level. But yeah,
I'm definitely not a bond trader here. So yeah, I'm just trying to explain it in a way that makes sense to me.
Yeah. Okay. Wow. Yeah. So realizing very quickly that Notional is a very just financially and like Solidity deep protocol here.
Yeah, I'll say okay. So I'll just get like my co-founder Teddy was an interest rate swaps trader at Barclays for like a number of years. So like he this a lot of this comes from his his understanding of finance and how things work.
Kudos to him. This is yeah, and to you. So. All right. Well, I think you said you'd like to dig into some external stuff as well.
Yeah, maybe see if we have time for like some of the like one of the externals.
All right.
Actions. Actions sounds fun.
Liquidation.
Don't do liquidation. It's fucking.
Where would depositing be?
Depositing being account action. Yeah.
So that maybe let's just take a look at a simple deposit then.
Yeah, account action would be the first one.
It's like right at the top over there. Yeah.
All right.
Okay.
Yeah, take it away, Will.
Okay, so I would say, is there actually a function called deposit? Maybe that'll be where we dive in.
Yeah, there is. Yeah. Well, there's two of them. There's one which is deposit underlying token, and then there's deposit asset token. So it's just like we handle. So if you deposit an underlying token, that would be like USDC or DAI. And like I said before, like we're gonna wrap that into C tokens. So in here, what it'll do is like it'll deposit, it'll like transfer from, and then it'll like mint some C tokens and like do the accounting for you. And then the other one will just like transfer the C tokens. So,
okay. So I say, I don't know, why don't we give a shot at this one then, eh?
Yes, sir. Do it.
All right. So this is payable. Is this payable for gas saving or payable because you can actually pay in ETH directly without wrapping it into WETH or WETH or however people pronounce that?
Yeah, we actually don't use WETH or I say WE. We don't use WE at all.
Okay.
So we just use
all right. So require that it's not an internal call. Interesting. Require valid account. So that's probably just so then we get context of the account. I take it the context is kind of like their balances already, so you know if you're topping off or doing like that.
It broke up a little bit there, but yeah, something like that. It sort of like tracks the like accounts positions.
Cool. Balance state. So you're loading that into memory. Balance state also. So we saw the balance states before. We're going to have one, so we just initialize that in memory, and we load that. Okay, using load balance state. Next line. So we have here. Loads for different sender deposit tokens into a specified account. May be useful for on-demand collateral top-ups from a third party. Okay, just-in-time stuff. Asset tokens received internals, balance state, deposit underlying token, message.sender, and safe in 256 to an amount external precision. Okay, so that's just the casting right there. All right. Could you explain actually, in that little note right there, basically what you're saying is that it is possible, like you can kind of see from the arguments in the function, that it's possible for Alice to deposit for Bob. She hits deposit underlying token, but she passes in Bob's address. Over here, specifically in that int 256 asset tokens received internal, though, you're using message.sender. So why is that?
Oh, right. Oh, yeah. So it's going to, okay, so on line 66, we're loading the balance state for the account. So that's Bob in this case. And then when we call deposit, we're going to say, take it from Alice. Like take it from Alice and then, but like put it into Bob's account. That makes sense?
I think so.
Yeah.
Okay. Require asset tokens internal received is over 0. Fine. Balance state dot finalize. Okay, an account. Okay, so this is actually just stuff internal funds. Like, I basically, you've got the loading, the casting, in order to figure out how much is coming in, make sure that that's still relevant, and then you're relying, I'm assuming, on finalize and set account context to kind of do the like internal like bookkeeping work to change whatever values and store whatever values need to be stored as a result. Is that correct?
Yeah, that's correct.
Cool. And then you just return the amount that Notional gets from it. What do you say, Ben? Should we try and hop down to finalize? Oh, finalize itself is a part of the struct. I was thinking that was a function. My mistake.
So that
isn't
be
a
the
function,
balance
is it?
handler. That will be the balance handler contract.
Is that a function being stored in the struct there, or is that?
No. So if you go up to the top of the contract, this particular one, there's a Solidity feature called using.
Yeah.
So like using balance. So then if you look at a lot of functions in balance state, it'll like pass the thing in memory. It's a little
I don't
like
know if
like
I've ever seen that used on a struct before.
Oh yeah, you can use it on struct. Yeah. You can use it on, I guess.
That's really, really cool. I'm feeling like a total pleb. There are so many things that I have seen in the last hour that I haven't seen used before. But making a library on top of a struct in order to make custom functions that you can use on that struct itself. Yeah, that's awesome, man.
Yeah, it cleans things up a lot.
I need to read more code. That's really what it comes down to, which is why I'm here. But I mean, like, yeah, that is really cool. Okay. Huh. So either we could drop into the finalize, or we could take a look at the other deposit. Like, Ben, do you have a preference?
I mean, I think we could probably go into the finalize because probably got an idea.
Okay, so Jeff, you said that would be in the balance handlers, like the same.
Yeah. I think you had that open.
This one. Finalize.
This is like a kind of like a beast of a thing. So So the idea here is that like with this thing is like like we had like we try to batch up like actions. So we try to do as much as we can in like a single transaction for the user, just because it's like that's like the most gas efficient thing you can do, and also it's like good UX. So basically like the idea of the balance state is that like as we like manipulate as like so say you're like trying to like do some stuff in DAI, right? So like if you're lending, you're gonna like deposit some DAI, you're gonna like lend it out, and then you're gonna like I don't know do other stuff, whatever. Like who knows, right? Like this function doesn't care. But when it comes in, like it's possible that you have transferred some N tokens. You've either minted or redeemed some N tokens, so that'd be like supply change. Your cash balances have like increased or decreased, or you've like I don't know, like had to transfer some cash around or what have you. So this thing is just going to check like sort of all the invariants that like should not be violated as a result of like all the things that you did, more or less. So it kind of just goes through that. So like those two if statements, like we can't never have like a negative LP token balance, and under certain conditions you cannot have like a negative cash balance. So it'll like revert under those conditions. And then after this, we'll do our transfers. So inside finalized transfers, we'll do like transfer some tokens around and handle like the accounting required there. And then we'll like accumulate. We'll like check how we'll like calculate how much cash has changed hands or to your account. And if it does, then we'll do some updating. We'll like set that boolean. We'll make events, and then and then like on line 158, we'll like also if your end tokens have changed, we'll also like claim incentives for you. And then the rest of it is kind of just like bookkeeping. So.
This protocol's so deep.
Yeah. I am super impressed by the code here.
Yeah.
Incidentally. Yeah. We should probably start wrapping up. Coming up on an hour over here. So I mean, as usual, like we've barely scratched the surface of what's going on over here, but this is a lot of really cool work. I mean, it's interesting, I guess, to even compare and contrast a bit. You've got like the thoughtful UX on a front end that helps the user figure out what they're looking at, what's going to happen, what they can do. And on the other hand, like, just watching a Solidity code base that's as mindful of how it stores information, how it accesses that information and moves it around. I'm really impressed.
Same.
Oh yeah, we didn't even look at the complex part. Yeah. I appreciate that, guys. This is sort of like I guess for Teddy and I, this is like I mean the teams do more than just two of us. This is like sort of it's sort of life's work, I guess.
Cool. All right, so it's like we're working on that over here. So yeah.
All right, so this has been Notional Finance. Guys, go check it out. It has one of the coolest UIs I've seen in DeFi and one of the deepest financially and like Solidity complex contracts I've seen in DeFi. So I think everyone would be very excited to go try this out.
Yeah, for sure. Yeah, thanks for having me on.
Sure. It was great. It's great to get your insight, Jeff.